Right, so good morning again, Mr. Katwaru here again, and today we are going to be looking at systematic error. We're not going to cook actually. I know you're seeing some red kidney beans and some peas and carrots, but we're not cooking today. We're continuing with systematic errors. So one of the most common systematic error is the error called the zero error. Now let's just recap from the video before. A systematic error is an error that will occur every time you make a measurement. And very often it's because of most likely an instrument that is, well, I wouldn't want to use the word faulty, but probably not calibrated properly, right? Or does not start exactly from the zero mark. So let's start with this particular instrument here. This is that regular household scale. This is actually the scale that Mr. Katwaru bakes with. I actually do all my measurements when I'm baking with this particular scale. It is only precise, of course, up to 2 ounces. I think I'm going to replace this scale very soon. So anyway, so currently, if you look at the needle at the top, the dial, it's exactly on the zero mark, right? And therefore, if I were to weigh, let's say, the red kidney beans, right, it's actually looking just like 1 pound there, just 1 pound. A little bit more maybe, but we'll call it 1 pound. Let's look at the peas and carrots. Peas and carrots looks to be also 1 pound. And then let's look at the pigeon peas. Also seems to be 1 pound. Right? So let's remember that these 3 items were 1 pound each, right? So I'm going to do something right now. I'm going to actually just kind of set the dial to 0.5. So let's just say there was something wrong with this scale, and the needle didn't start at 0, but instead started at 0.5, 1/2 of a pound. So if you notice, every time, let's reweigh these items. So let's start with the kidney beans. It weighs 1.5 here. All right. And then let's start with the peas and carrots, also 1.5. And then the green pigeon peas, also 1.5. But of course, we just weighed these 3 items and found the mass of each item to be 1 pound. So clearly, each time you measured, there was an error. The error in the measurement was 1/2 of a pound. And that's because this particular scale did not start at the 0 mark. It started at 1/2 of a kilogram. The thing about this is systematically, no matter what object, what you weigh with this scale, once it does not start at, it starts at, let's say, 0.5, everything that you measure will be 0.5 or 1/2 of a pound heavier, right? But since we know all of these items are going to be 1/2 pound heavier, we can just pretty much just minus the 0.5 from, in this case, the 1.5, right? And we will get the exact mass of the item, which is 1 pound. So a systematic error, as you see, happens each time, right, you make a measurement. But because we know it's going to happen and we know how much error in the measurement is, in this case it's 0.5 pounds, we can pretty much just subtract it from all the measurements we make and therefore eliminate the error completely. This, of course, cannot happen with random error. Random error is, it can happen at any time. We really can't predict it. And therefore, if we don't know it's going to happen, we certainly can't eliminate it. And that's why random error, of course, we cannot eliminate, we can only reduce. And as we learned previously, the best way to do that is to repeat the experiment or the measurement many times, right, and take an average, right? However, that taking the average of these items, of the measurements you make with a scale that has a systematic error, a zero error like this, right, is not going to help, because no matter how much you were to to measure these items and then find the average, it's still going to be inaccurate, right? And we don't have to do that because we know what the error is, so we can simply just minus that 0.5 from each of the readings we take, and we'll get the actual accurate or correct value, right? So I hope this kind of clears up what random error is. Now, I know you would have seen me adjust the scale to 0.5, right? And that's only just for the purpose of this video. But very often when we use certain instruments, whether it's a measuring scale or some sort of other measuring instrument, very often they don't tend to start from zero for whatever reason. But that does not mean that you can't use the device. But if you know it's giving an error of 0.5 or 0.25, then every measurement you take, you just pretty much have to minus a 0.5 or 0.25, and you can eliminate that error in measurement. So that's it for today. That's basically what the systematic error, which is an example of which is the zero error, right? Comes about with scales. So I'll see you in the next video. Take care. Bye.